Hi everyone, it's Dr. Young. Today we're going to be exploring what are waves. So first, we're going to start talking about the parts of a wave. A wave has several parts that occur all along its path. So here we have a pretty basic wave, and the first part we're going to talk about is the amplitude of a wave. The amplitude of a wave goes from the top of a wave down to the middle of the wave. So this is half the distance from the crest to the trough of a wave. So this is called amplitude. Next, we have the crest of the wave. The crest of a wave is the top of the wave. Then we have the trough of a wave. Trough sounds like it's going to be spelled T-R-U-F-F, but it's actually spelled T-R-U-O-U-G-H. So that's the trough of a wave, the bottom of the wave. Then we have the wavelength. The wavelength is the distance between waves. So that's called the wavelength. You're going to be learning a lot more about wavelength especially, and amplitude, and how those translate to different sounds later in our lesson. Now that we've learned about the parts of a wave, we're going to learn about some more vocabulary that are going to carry you through this week and next week. Our first vocabulary word is opaque. Opaque is when something does not allow you to see through it. So this means that you can't see through it. For example, my whiteboard that I'm drawing on right now is opaque. You can't see through it. It doesn't allow any light through. The next word is volume. Volume is how loud or soft something is. The next word is reflection. Reflection is when light bounces off of a surface. We do also call what we see in the mirror our reflection, but for the purposes of this lesson, we're looking at reflection as the way light bounces off of a surface. So we see the light coming in here, and then it bounces off of our surface. The next word is wave. Pretty much what we've been talking about this entire time, and what we will be continuing to talk about. A wave is the up and down movement of surface water. It can also be a disturbance that carries energy through space. So here we're going to be thinking about waves in one of two ways. This is the energy disturbance as it carries energy or sound through space. But then there's also the type of wave that you see when you're at the beach. And that's what these waves are here. Lastly, our final vocabulary word for the next 2 weeks is translucent. Translucent is actually the opposite of a word that's already on our board. Can you guess which word it is? If you guessed opaque, you are correct. Translucent and opaque are actually opposites. So these two words are related because they are opposites. And the way that they are opposites, let's think about this for a second. If opaque means that no light gets through, what do you think translucent means? If you guessed that translucent means that some light can get through, you are correct. So for example, let's say you have a glass of apple juice. You'll notice that you can kind of see through the apple juice itself. It's translucent, okay? So the juice itself is translucent, okay? Your science book uses a jellyfish as an example. It's saying that you can see through the jellyfish itself and then there are parts of a jellyfish that are translucent. So there's your vocabulary for the next 2 weeks. Now that we've explored our vocabulary for this week, we're going to start thinking about how waves transfer energy. Did you know that you can actually see or experience waves every day? A wave can be the up and down motion of water. It can also make a flag wave. So perhaps you have a flag in your neighborhood. Flags can wave through the wind that creates the wave. Have you ever thrown a rock into a pond? If you throw a rock into a pond, you might notice that it creates ripples. Those ripples in the pond are also a wave. The size of the wave is related to the amount of energy that gets transferred. The rock that was dropped into the pond originally was pretty small, but the energy of the drop itself and the rock hitting the water created the waves. Now let's talk about waves in the ocean. Waves in the ocean can carry a lot of energy, and today I'm going to show you exactly how that happens. As a wave gets closer to the beach, the land underneath the water is closer to the surface, causing the energy in the wave to force the water to rise up. So here we have our wave, and here we have our sand. So this is all sand, and as you can see, the sand is getting deeper as the wave itself gets closer to shore. So in our picture, shore is actually right over here, and out to the ocean is this way. Wind transfers energy to the ocean's surface, causing a wave to form. Each circle shows the movement of water up and around in a wave. So as you can see, the wave's motion starts slow, and then it gets bigger and bigger and bigger and bigger until a wave breaks on the surface. Notice that the water doesn't move forward. Only the wave's energy is moving forward, which is shown by the red arrow. As the water becomes more shallow, the water has less room to move, forcing the water to move higher into the air. So as you can see here, although the energy still is increasing, it's a less distance than it was here. So from here to here, we have this much distance, but from here to here, we only have that much distance. And so on and so forth as the wave gets closer and closer to the shore. The height of the wave increases and the energy moves forward more slowly. Now we're going to show what happens when the wave is right on top of the shoreline. So here we have our sand that's getting deeper, and then we have our shoreline. The waves move toward the shore until the shore forces them to break into an actual wave like what we see, and then it meets the shoreline. So we still have the energy out here getting further and further along, and we can still see how the energy is transferring from the ground to the top of the wave, until finally, right as the wave is breaking, the energy transfers into the shape of a wave. And the movement of the energy is still going this way, as evidenced by the red arrow. When waves get close to the beach, the back of the wave moves faster than the front of the wave, causing the wave to break. All that energy needs a place to go, and as the water crashes onto the shore, some of the energy is transferred into sound, and some causes beach erosion.